Okay.
Wait, hold on. Not on the screen.
Okay.
Okay. Welcome back to MAYhem, everybody. We're here with our follow-up interview with Zoe Dietrich, all the way from New Zealand, and we have a wonderful panel of guests, including infamous or famous Mr. Maiden. Yay. Okay. Annika Donk. Yay. Science wizard Jackson Perkins, right there. And of course, Zoe. And I'm Amy Hankinson, and we're gonna just get started with the questions right away without further ado. First of all, let me just say that the questions that I received, really good job, nice, deep level, higher level questions coming from my students, so I really appreciate that. And I think the other science teachers feel the same way, so way to go. We're gonna start with some general topics, Zoe, just kind of general information about you and your talk. And one question that I received was, or one of us received is, if climate change keeps growing as a problem at its current rate, how long do you think it will take for the effects to be irreversible?
I mean, that's an interesting question because a lot of positive feedback loops have been set into place by the warming that we've had so far in climate change. And so a lot of loops we see are like, for example, ice caps in the poles melting actually has this effect where it causes the poles to be absorbing more heat, and this causes further and further melting. And so a lot of these feedback loops have already been set in place, and scientists are working really hard to understand kind of where we are and how long it's going to take and if they're even reversible. But I mean, I think the short answer is we don't really know yet.
Yeah.
Yeah. But that is an interesting thing, is that I think right now a big push in the climate crisis movement is to try to stop, you know, now, so that we don't get into an irreversible place in one of those feedback loops.
Yeah, yeah. I agree, it's complicated.
Very much so. I think I have a question too, which is, for you, Zoe, was there a turning point in either your high school or college experience that really made you feel passionate towards oceans and the impact of global warming?
Yeah. I mean, I guess I never took APES the ocean science class wasn't offered when I was at Sehome, and so I did not think I was going to go into oceanography or any sort of environmental science until I got to Bowdoin. And then I just kind of happenstance decided to take an intro oceanography class out of the blue my second semester. And it just absolutely rocked my world. And that was definitely the turning point. And I wouldn't say, I mean, of course I grew up in Bellingham. Of course I love the ocean and all that jazz. But really, I just love ocean science because it's so fascinating. And I love thinking about all the systems and how everything is interconnected. And I mean, I tried to show that physics, chemistry, and biology are all wrapped up in everything. And that's truly what I love about it. And so, yeah, that intro class was definitely the turning point. And I wasn't even planning to be an earth and oceanographic science major. And then, you know, wasn't really planning on it. And then I just kept taking classes, and so that was definitely the turning point my first year.
Okay, so I think I have the next question, which is kind of related to why we're all on Zoom in the first place, which is COVID-19 and the impact on the environment as far as some positive clean air impacts. So students were wondering, do you think that people will take action for climate change, or do you think that the current health crisis will distract us from the more gradual threat of climate change?
That's a really interesting question. I mean, obviously COVID-19 is at the forefront of all of our thoughts right now. I have been reading a lot about how huge cities are having the cleanest air that they've had in like decades. So there definitely are some positive impacts just in terms of emissions and everything. But just in terms of attention to the climate crisis, I don't know if any of you have heard of the Sunrise Movement, but it's this big movement with young people all across the country, mostly centered around like hubs and undergraduate institutions. Like Bowdoin has one, a lot of schools have them now. And so they're really fired up. I mean, and a lot of that movement has to do with intersectionality. So thinking about climate change, but also thinking about healthcare and all of these other issues wrapped up into one. And so, I mean, I'm part of the Sunrise Movement. I've just been getting emails from them, and they're, I mean, very on top of it and as fired up as ever. So I wouldn't say necessarily that COVID is whole scale distracting us. Obviously, it's at the forefront of our minds, but yeah, I think, yeah, I mean, it's an interesting time that we're in right now, and it'll be interesting to see how it shifts what people think. I mean, one thing it's showing us is that people can work from home and not commute, and things can keep running. And so who's to say that, I mean, certainly not all, but some jobs shift to more remote work in the future in order to help with the environment. I mean, there's possibilities that it's opening up also.
Great.
Okay, our next question is, what is it like doing research at a liberal arts college?
And maybe describe what a liberal arts college is, because that was in my questions also.
Okay, so I go to a liberal arts college. Basically, a liberal arts college is just any college that has about 2,000 or less students. And so when I was applying to college, I don't know, I thought about what really mattered to me. And what I really loved about Sehome was knowing my teachers and being in classes where I wasn't afraid to talk and speak out and just really get to know my classmates and be in small learning groups. And I mean, that's what a liberal arts college is there's only about 2,000 students. So all of your classes are pretty much 30 or less people. All my professors know my name. I love them. I just stroll into their office all the time and just chat about anything. You know, always speak up in class. Yeah, the group learning is huge. The individual attention you get from professors all the time is huge. And, you know, the advising, and they just care so much about me. And so I think that was the biggest part about choosing a liberal arts college. Then the second part of the question was, and I would say at liberal arts college, I mean, people don't really know about them because they aren't publicized as much, but I mean, obviously feel free to ask me questions or look them up. There are definitely more on the East Coast than there are on the West Coast, but there's some great ones on the West Coast too. Okay, and then the second part of the question about research was, I mean, that's another thing, is that when you're in a pool of only 2,000 kids, it's a lot easier to have access to everything. And so it was super easy for me to get an on-campus research internship my first summer at Bowdoin. Yeah, I just reached out to a random professor, said, hello, my name is Zoe. I'm interested in this. Can we chat? And they're like, yep, come to my office like tomorrow. We'll have a chat. And then it just goes from there. And yeah, I absolutely loved it. There's at least, Bowdoin, and I'm sure all the other liberal arts colleges have a ton of research opportunities for students. It's like their number one priority for summer. And yeah, I had a fabulous experience. I mean, one-on-one attention from the actual professor the whole summer. I learned a ton. I got a lot done. Yeah, it was a great first experience. And then it really sets you up well to go out and apply for opportunities at bigger research universities later on.
Cool. And so a lot of students, I've been selling this fact that you're live with us, not really live, but coming to us from New Zealand. And I keep just saying from New Zealand, and then the students, some of the questions were, well, what are you doing in New Zealand? So
yeah. Okay.
Can you tell us a little bit about that?
So yes, I'm in New Zealand. I originally came here because I'm studying abroad this semester. And so I'm doing a geology program. I'm definitely on the ocean side of things, but I thought geology is important. The oceans are surrounded by crust. You have to understand the whole system. It's all one big thing. And so I was like, I've never taken a geology class before, but I was like, I'm just going to delve into this geology program, which ended up being a great decision. But it was a 5-week field camp in New Zealand before the semester started, and then including a semester here in Christchurch at University of Canterbury. So yeah, it's been great. I'm taking 2 geology classes and doing an independent research project here also. So I mean, I think I learned more new words in the first 3 days of that program than I have in the last 3 years. I'm not kidding. It was just like, bang, bang, bang. But yeah, it was great. So yeah, a lot of students were sent home by their home universities when, in mid-March. But luckily Bowdoin gave us the choice of whether to stay or go, which I feel very fortunate to have been given that choice because a lot of people weren't. And yeah, a couple friends and I here decided to just stick it out in New Zealand and stay as long as we could. And it's worked out well so far.
Cool.
Mm-hmm.
That's awesome. So now we have some questions about circulation
Cool.
for you. And the first question we have is, what will happen in 1,000 years or sooner when carbon is released into the atmosphere from circulation?
I mean, essentially, it's just going to be a lot of what's already been happening, but faster, and that more CO2 will be being released into the atmosphere that's being stored in the deep ocean for all that time. And so, I mean, we're pretty far out from that right now. 1,000 years is quite a ways away. But yeah, it will happen eventually, is that water will come up and the gases, I mean, it's called upwelling when the water hits the shelf and comes up, releasing the gases into the atmosphere.
There was a follow-up to one of my students asked about that. I'm just going to double check it's not on the list already, but it was, how is upwelling being impacted by how the ocean is changing? If you could just really quickly comment on that.
How is upwelling being changing? I mean, upwelling is very complicated.
Yeah.
The deep ocean circulation is only one type of large-scale upwelling, but there's also upwelling that happens from wind-driven currents onto continents. And so, I mean, I guess I can't think of any specific examples right now of how upwelling has been impacted by climate change specifically. But yeah, I'm not sure. I mean, again, going back to the point that all these things are things that scientists are actively studying right now, trying to understand. But there's a lot that goes on with upwelling other than just gases coming up. Nutrients are also brought up from the deep ocean. And so upwelling, oftentimes when you have upwelling, you have big phytoplankton blooms and high productivity because you have those nutrients being brought up. And I mean, I'll just explain it briefly, but it's actually because when you have the phytoplankton being decomposed by the bacteria, like I talked about, their phytoplankton bodies are releasing those nutrients that were in their bodies back into the ocean water. And so when you have the ocean water coming back up to the surface, it's not only bringing CO2, but it's also bringing all those nutrients. And so upwelling is actually really important for coastal systems and fisheries because phytoplankton are the base of the food chain and they feed everything.
Yeah. Great.
All right,
My
I think,
question next.
I'm not sure. I thought it was mine.
Yeah, maybe yours. Yeah.
And mine is kind of related to upwelling as far as ocean currents go.
Cool.
Somebody asked about convection currents not going to Antarctica and whether Antarctica has an effect on cooling of ocean water.
Oh, certainly. It certainly does. So remember the box I showed you, the convection? You can almost think about that as just flipped over with Antarctica as well. And so actually what happens is, remember I talked about the water cooling in the Arctic and sinking? It actually cools in the Arctic and sinks, and then it flows down from the Arctic all the way to Antarctica, and then it hits Antarctica, so it upwells. But Antarctica actually cools it down also by the same processes. And so it creates this water called Antarctic bottom water that then sinks because it's the most dense, goes all the way down to the very bottom of the ocean. And it's actually really interesting because the way, and basically the bottom of the ocean has topography and mountains and valleys like the land does. We just call it bathymetry. And so the way the bathymetry is around Antarctica is that it funnels that Antarctic bottom water out in all directions. And so it goes out basically in all the ocean basins from Antarctica. But it also produces Antarctic intermediate water that then flows along the surface like we talked about in the model. Yeah, and so Antarctica certainly plays a role. It's all the same processes, just flipped over on the other side of the world.
Okay, our next question is how do they predict this slowing of the global ocean circulation will impact climate change and carbon?
Sure. I mean, one of the biggest impacts that people are worried about right now is weather. And I'm going to be honest, I don't understand this super well myself. But ocean currents have a lot to do with what's going on in the atmosphere and winds and different pressure zones. And so basically, if you're changing ocean circulation, it's going to change a lot about air circulation also. And so they're worried that as ocean circulation changes, it's going to have big impacts on big, like large storm events and hurricanes and all those types of things. And so that's one of the biggest concerns right now. But then you said what impact it has on carbon too. And I think the biggest impact is that the CO2 will start being upwelled into the atmosphere over time. But yeah, that being said, it's going to continually take it up through the biological pump that we talked about.
I think it's me. Is it me? Well, actually, Zoe, you just kind of answered the next question, which is what kind of weather changes can we kind of be predicted? And so I think you just answered that one. But one thing to remember too is just that the ocean circulation carries all of the heat around the planet essentially because of the high heat capacity of water. And so when you're carrying heat from the equator to the poles and that slows down, you're not getting as much heat moved.
Oh, sure.
Yeah. Anyway, but my question's been asked and answered, so way to go.
I mean, yeah, and that's another thing to think about is the ocean also really moderates the temperature of land it's next to as well, which is why we have the temperate regions near coasts. And so if you have the ocean heating up, it's going to, cause a lot of impacts with heating up of land as well.
Yep.
And that's something that we talk about in AP Environmental Sciences, talk about why the term global warming kind of was moved away from. And there's places like England that if the currents slow down in the ocean, England could actually see cooler temperatures because they're not getting the tropical water coming up from the Gulf Stream. So kind of talking about the term climate change instead of the term global warming. That had to do with ocean circulation as well.
And there's a really fun kind of pop movie that came out 12 years-ish ago called The Day After Tomorrow that plays on that whole thing. And, if you're looking for a throwback, that's a good one.
All right. The next section of questions we have are about biology and ocean biology. And we had a question that was wondering about how changes in sea temperature will affect organisms and sea life.
Sure. I mean, temperature is one thing, and a lot of organisms, they need to be in an ideal temperature range. And it's kind of like I can't draw this, but like a curve like this. I think it might be called a bar curve.
Bell curve.
Yes, where they have an optimal temperature, and they can survive at lower and higher temperatures, but it's not ideal. But I would also add to that another thing, and I don't want to get too much into ocean acidification because of Carter next week, but it all, it has a lot to do with the CO2 that's in the ocean, and then that ends up reacting with water to form carbonic acid and making the ocean more acidic. And so that more acid kind of lowers what we call the saturation state of certain minerals that these organisms need to precipitate shells, like clams and oysters and kind of all these things we rely on for seafood. And so basically when it's more acidic, the saturation state of these different minerals is lower, which makes it harder for organisms to build their shells, basically. And so it's temperature, but it's also acidity that kind of goes along with climate change and organisms and the ocean.
Yeah. And just, you know, for people out there watching, we will be having next week, we'll be having a more thorough, in-depth discussion of ocean acidification.
Okay, I think maybe it's my question, which is about plankton and bacteria, which is how does the relationship between plankton and bacteria affect other marine life?
Affect other marine life. I mean, basically everything in the ocean is interconnected. Like, it's not just relationships between plankton and bacteria, but between plankton and bacteria and fish and, you know, clams and whales and like all these different things. And I mean, bacteria grow everywhere and, you know, grow on everything. And actually, a lot of organisms have really specific, what we call microbiomes, which are communities of bacteria that live in them and on them, that help regulate different chemicals and things for their bodies. And so, and I mean, that the same goes for phytoplankton. Different phytoplankton communities often associate with specific bacterial communities that help them regulate different things. And so, yes, everything is kind of wrapped up together. I'm trying to think of any more specific points I'd want to make on that. But yes, I mean, the general concept is bacteria are decomposers, and phytoplankton are primary producers. And phytoplankton, you know, feed everything in the ocean. They're the base of the food chain. Yeah.
Awesome. Our next question is, how are climate change effects in the ocean affecting life on land? And they also added, habitats in the ocean and on land are connected in many ways. I'm curious to know how those connections are suffering.
Are suffering. I mean, I think the heat thing we talked about earlier is a big one, of how the ocean modulates the temperature of the land. I mean, sea level rise is another big one that coastal communities are going to be struggling with and are already struggling with. Just because, I mean, there's kind of two main factors that are driving sea level rise, and one of them is melting of ice in Antarctica and the Arctic, which is literally putting water into the ocean. And the other one is something we talked about in the very first slide of my talk, which is that as the water warms, it's going to expand, which is actually contributing significantly to sea level rise. But sea level rise is also interesting because, like we talked about, how you shouldn't call global warming because not everywhere is warming. It's kind of interesting also because we're like experiencing sea level rise, but we're not experiencing sea level rise everywhere. And one thing I find really interesting is that, like, for example, when these big ice sheets melt, the sea level actually drops in those locations in the poles. And it's because the ice sheets are so huge, you actually have gravitational attraction of the water to the ice. And so once you lose that ice and it's melted, you no longer have that gravitational attraction. And so sea level goes down in those local places, whereas it rises in other places.
Wow, that's really interesting.
I know, I thought that was awesome.
It's like mind-boggling.
Some of these ice sheets are just huge, and when they calve off, it's
yeah. So a little side note on that, maybe you knew this, Zoe, but Dr. Maddie Smith is our speaker for this week, and she's actually up in the Arctic on the Mosaic mission studying the physics of ice sheets. And so you
should have her talk about it. Yep.
Yeah, she's not able to meet with us live, so she had a webinar that we posted, and you should check it out. But interesting to the viewers out there, Dr. Maddie Smith went to Bowdoin also, which was not planned, and Sehome. So we've got a real series here. Okay, my next question is right in the middle of biology, which, as you well know, I know a lot about. Could our plankton eventually get carbon saturated could our CO2 emissions outpace the amount they can store until eventually they will only store like 20 to 15% of the output?
Oh, I think absolutely. I mean, phytoplankton aren't limitless. They can only take up as much CO2, as they can do photosynthesis at whatever rate they can do photosynthesis. And so actually, it's a really interesting problem because a lot of people have experimented with the idea of if we put more nutrients into the surface ocean, will we have more phytoplankton that will then take up more CO2 and bring it down into the ocean? And so I just read this, basically a lot of times the most limiting nutrient for phytoplankton, at least in the Southern Ocean, is iron.
Yeah,
and so people have talked about doing iron fertilization in the Southern Ocean where they bring in just like mass. A lot of times iron comes from dust. And so you don't really have limitation from iron on like near continents where dust is coming off and going into the ocean. But in the Southern Ocean, there's no real source of dust. And so it's really iron limited. And so people have talked about going and basically spraying a bunch of iron onto the water and seeing if they can make phytoplankton blooms. And basically, the long story is it doesn't work. But people people have thought about this idea of trying to increase phytoplankton to take more carbon out. But basically, yes, I mean, phytoplankton have limits. They can't just take up, they're not going to, increase their capacity as we put more and more CO2 into the atmosphere.
So kind of building off that, our last question for the biology section was asking if the processing of CO2 that phytoplankton do, if there is a way to cultivate them or maybe artificially replicate their process in order to pull more CO2 out of the atmosphere. And you touched on the iron limiting, but is there any possible way that you've heard of that we could cultivate or artificially replicate their process?
I mean, that would be great if people could somehow genetically engineer a phytoplankton to take up more CO2. I haven't heard of anywhere where that's been done. But yeah, it's definitely an interesting idea people have toyed with. Is there some way we could cultivate phytoplankton to remove more CO2, or something like that in the ocean? Yeah, to be honest, I don't really know. I mean, if it'd be great for people to go into that and try to figure out a way to make that possible. But yeah, I mean, there's a lot of caveats in the ocean that it's a lot more complex than it seems at times. And so oftentimes you introduce a new factor and it kind of backfires. Just because there's some other relationship or process that you're not considering when you're making those changes. And I mean, a good example of that is in like food chain dynamics, like when people introduce predators or prey expecting one or the other to go down or up in abundance, and then it ends up impacting some other predator or prey they weren't even anticipating, and causes like some inverse effect.
Yeah.
Okay, let's see. I have a question that kind of wraps back to the last question I asked, which is about the Arctic and Antarctic warming up.
Yeah.
And it's about your diagram. And I think you kind of maybe answered this already, but would the diagram you showed make it so both ends are heated, aka there is no source for colder water?
Make it so both ends are heated?
I think the top and the bottom of your diagram are not cold, I guess is the question.
I think that's referring to like as climate change increases and like they keep getting warmer, how would that affect the diagram?
Oh, if you just have more warming at the surface, you mean?
Yeah, I think they're saying as if they're just like, I think you answered this question potentially in your talk, Zoe, but I think the question is they're just reiterating the fact that as you get the melting of the caps at the poles, that's going to not drive the cold water quite down as fast, and so you don't have these big density differences.
Sure. I mean, yeah, as you have more warming at the surface, that surface water is going to be warmer and warmer, making it less dense, and causing it to not sink as fast in the poles. But yeah, I guess just to clear it up, yeah, the surface, so the top of that diagram is warm because it's being lit by the sun. But then the bottom is always going to be cold no matter what, because that's in the deep ocean, about 4,000 meters deep. That's very cold. No sunlight reaches down there. And so I don't have any data on this, but just off the top of my head, I don't think that the deep ocean is going to be warming anytime soon.
Okay.
Okay, I think this brings us to our last question of the day, which is kind of a chemistry focus, and that is, does carbon dioxide in the atmosphere precipitating an acid rain affect the oceans? And if so, how deep in the ocean does it impact the oceans?
Yeah. I would say yes. I'm sure that it contributes to the acidity of the ocean. I wouldn't, this is also not based on data, I wouldn't say it's probably a large fraction, but yes. And I mean, one thing to consider is that when you're raining, the rain coming down is fresh. And so it's probably not going to penetrate very deep into the ocean because fresh water is less dense. And so it'll kind of stay at the top before mixing. But yeah, so I would say maybe that has a small impact on the surface ocean, but I wouldn't say it has a huge impact overall.
Well, that brings us to kind of our last question and our wrap up. First of all, we just really would like to thank you, Zoe, for giving us your time and your inspiration and your thoughts on this. Something that we're going to be asking all of our speakers, maybe because this topic can get, a little bit heavy, is just maybe you could comment on something that gives you hope in regard to the situation. And then we'll just wrap it up from there. And if it's okay with you, if people have further questions, I could put them in touch with you.
Sure. No, I would love to. Yeah. And I think I put my email on the last slide of that PowerPoint, but feel free to send it out. Something that gives me hope. I mean, I think there's two things. I think there's the social aspect, which is like the sunrise movement that I mentioned earlier, and all of the attention that the climate crisis is getting right now. Especially from young people, which is super awesome. And we need to keep it up. But I would say the second thing that gives me hope is that I think it's easy to hear about all these ice sheets melting and everything and think that all of these impacts of climate change are so bad and blah, blah, blah. And I mean, some of them are, but there's a lot of it that is really interesting and really exciting to think about, and also is actually kind of good. And one of those is that, I think I mentioned this in the talk, is that because of retreating ice, we're actually seeing a lot higher productivity in the Arctic, a lot more phytoplankton blooms that are happening earlier and for longer. And this is actually like feeding the food chain up there. And so we're seeing a lot more of other animals thriving. And, that goes both ways. There are winners and losers. As one of my professors loves to say, there are some that are really struggling, of course, but some are doing better. And so there are always these ups and downsides, and I think it's easy to focus on the downsides. But it's also it's just really interesting from a scientific perspective also to think about how all these things interact. And it's kind of just a really neat challenge that we have ahead of us as climate and ocean and earth scientists going forward.
And maybe one more question, which a lot of students asked, which was, what can they do to help the situation?
So there is some good to be said for individual environmentalism, which is kind of those actions that we do, is like turning the lights off and, biking and walking instead of driving and stuff like that. And that matters, but almost what matters a lot more is just getting out and voting. because we really need large scale mass change in order to see changes in our environment at this point that we're at, and we need policies. And so really getting out and voting and making your voice heard is really the best thing that you can do at this point in time. Yeah.
Does anybody have any other follow-up questions or any comments? Oh, you're just the best, Zoe. Thank you so much.
No problem.
Okay.
Yeah, feel free to email me, reach out with any more questions. I'm happy to, email or
All
chat.
right. Enjoy New Zealand. Get out there and surf my favorite wave.
I boogie board, but yes.
Perfect. Okay, bye.